What's up, my dudes? We're gonna go look at some graphs. This will be like the third game that we're gonna play in our 2.2. I mean, as long as it's summer, fall, I'm talking to you. So we're gonna start looking at some graphs. I got one cooked up for us. Bang! There it is. There's a graph. Got some shit written over on the side. But let's just look at this first. All right, we got some sort of crazy ass graph. There's no parent function that looks like this. This is all cooked up, mean math teacher, thrown together. But it's a great tool for being able to figure out what a limit from the left, the limit from the right, and what a limit actually is supposed to be. So why don't we go take a look at some limit problems? So our graph here, the curve in red, is y is equal to f of x. So each one of these limits, being asked, sorry for my shitty handwriting. Hopefully you can read this up. We're looking at our first one. It says the limit as x goes to 10 of our function. Okay. No lefts, no rights, no nothing. But we see right there at 10. When we're talking about the x is going to 10, look at the x values. Now what's the y value? Huh? It's a continuous function. There's no hole. There's no issue. If we come in from the left, we go to 10. If we come in from the right, we go to 10. Right? Oh, they say 10? Shit, I shouldn't have said 10. That's the x value. Limits don't pop out x values. Limits pop out y values. And if we're on the x-axis, that must mean the limit as x tends towards 10 of our function f of x is equal to 0. Because right here is where y is equal to 0. Cool. We move on to our next one. We want to look at the limit as x tends towards 6 from the negative side or from the left. And we want to figure out where it's tending towards. Where's it pointing at? Let's go. Let's find something to the left of 6 and we'll just follow it. You're like, all right, wherever we're pointing, cool, we're pointing right there at 6, huh? From the left. And now we just want to check and see what that height is. And that height is 2. Yeah? Height's 2? Let's go. So we write in 2. Limits from the left and from the right almost always exist. It's not always the limit period exists. Cool. Moving to our next. We see the limit as x tends towards 6 from the positive side. So we follow it on up. From the positive, we hit 6. We want to check out that height, and that thing is equal to 5. So our answer is 5. So cool, we looked at the limit from the left of 6. We looked at the limit of the right of 6. And we got 2 different answers. So I'm pretty sure 2 doesn't equal 5. Therefore, the limit as x tends towards 6 just period. That does not exist. If we were in class, I'd be trying to put my fingers together saying, if you follow them together, your fingers need to point to the same spot. If you go from the left and the right, you need to be pointing at each other in order for that limit to exist. All right, next one, the limit as x tends towards negative 8 from the negative side, right? Negative 8 from the negative side. All right, let's go. From the negative side of negative 8, we follow it and we look and we're like, oh, there it is. We're pointing at negative 8, but what's our height? We come over and we're like, oh shit, it's negative 6, right? Our height's negative 6. So that must be what our limit is. Well, when we go to check out from the right of negative 8, from the right, I'm like, wait, it's pointing to the same freaking height. Dude, it's just negative 6. So we jump up to that 7th little part there, which asks us, well, frick, what's the limit as x tends towards negative 8 of our function f of x? Well, since the limit from the left is negative 6, and the limit from the right is negative 6, well, we have that theorem. It tells us that the actual limit is equal to negative 6. Now, there's no functional value there. Right here, there's a hole. Limits don't give a shit if it actually achieves the value. It's just what's it pointing at. It's pointing at that hole. This is 90% of the games we play with limits. It's a removable discontinuity or a hole has been placed there. So the function doesn't exist. So in number 8, it's asking you what's the functional value. If you say, what's f of negative 8, and we can look right above it. There's that point right there at negative 8 comma negative 3. So That's saying that answer is equal to -3. This is a very big thing here. The limit doesn't actually have to equal the functional value. The limit is just what something is tending towards. It's what it's getting as close to. You know, all that like arbitrarily close to something is sufficiently blah, blah, blah. Yeah, it's just shit that's getting close. All right. And keep going. We move on to our next number 9, and it says, let's go find that limit as x tends towards -2 from the left-hand side. So let's go from the left-hand side of -2. We point up, we look, and we're like, shit, that's got a height of 3. Let's go. Boom. Now let's take the limit as x tends towards -2 from the right-hand side, and then we get to introduce one of our first little topics there. On the right-hand side, we're like, where's it going? Oh no, it's blowing up. It's getting infinitesimally large. There must be some sort of asymptote going, you may not pass, hanging out right there. This actually can't be an asymptote because we have a functional value, blah, blah, blah. I digress. But where's it going? Where's that thought idea that's not actually a number, it's just a concept? Don't ever write it down that it's a number. It's just saying it's tending towards infinity. Well, since 3 sure as hell doesn't equal something that's a concept, cat doesn't equal 4, all right? Infinity never equals a number, so we can say for certain that our limit as x tends towards -2 does not exist. Now here's the games you're going to play on pretty much a smaller scale until you take your exam. I'll give you something pretty much very, very, very similar to this with a couple more concepts in it. So make sure you can play these games with some graphs. I think you got 3 or 4 of them throughout your homework. But it just helps us to understand, like, what the hell's going on. And if you're still sitting there going, like, I don't know what a limit is, that's cool, bro. It's cool. You won't. Give it some time. I just ask you to bear with me. Keep trying to play this game. Learn this little notation. And should start coming a little bit more clear as we go along. All right. I'll see you in the next one.